create everything I'm creating, I'll be going rather quickly. So please, just hang on for a bit. All right. So yes, I've just started a recording process. Yes, it's recording. All right. Minimize. All right. So right now, what most people have in their designs is they have. I hope everyone can see. Lights off. It's not the best, but we'll try. All right. So I'm just going to make a simple students who are going to be ordering some food at a corner or some canteen. Right. So very quickly. In future, I expect that you yourselves can, even in an exam situation, very quickly create for me a database. So I just have a student ID, first name, last name. Right. So right now, you do know that when you go to a corner to buy food, they have a database that records who bought what. Right. So we are going to do something like that right here, very quickly. So you have a student. Right. You also have a cashier. Come on. Who also has a first name and a last name. You also have some meals that the Akono serves. I keep saying Akono, but maybe any canteen. I just say any canteen. Because I think there are now 2 canteens on campus, right? So that's some ID, name, description, and then some cost. So what do you use for the cost? What do people suggest we use? Is integer good for cost? What if it's 4 cedis 50? Okay, so decimal is one of your options. Some people may also use, there's numeric as well. See if I can find. Numeric and decimal, they are all very similar. But for money purposes, decimal is our favorite. Why wouldn't we use something like float? Do people remember from programming 1 or 2? Why wouldn't we use float or double? So computer science people, why not float or double? What is the difference between a decimal and a floating point? Or what do you know about floating point numbers? Okay. Not an infinite number. Okay, so floating points, they are designed to be almost approximations, to have a whole number part and a power part. So a floating point number, just, what's my notepad? Okay. For a number like this could be 1.0 times 10 to the power, however many I have here. Maybe I didn't count properly. But usually what happens with floating point is the computer will try and store the number in this type of format, right? Where you have a whole number and a fractional part. And what happens is sometimes if a number is maybe like this, the approximation may lose out on the smaller part. Right? Because even if I said, okay, I'm going to use even 10 digits here, I could adjust the whole number in a fractional part. But if I am not careful, I could still be losing some precision. Right? So I think you may have seen this in physics class, or maybe chemistry class in SS. That anytime you are given a number, you try and write it in some format like this. But the danger is if the number is too large or too small, or the number has 2 components, especially where one component is very large, one component is very small, you may end up dropping the smaller part. Right? But for a decimal, the restriction between numeric and decimal is Usually, when you define a decimal in your computer, you'd have to, well, for a database, you have to specify the precision and scale. So when I say precision, I mean this part. So there are two numbers. And what this means is that this is a 10-digit number, 2 are for decimal. Same for numeric. If you define numeric, it's the same thing. They're just different ways of calling the same thing. Right. So it means if I'm storing a number like 10.20, that's fine. If I'm storing a number like 12. This is not very good because what? I'm going to lose the 2 decimal because my limit here I've specified what? 2 decimal places. If I do this, I'm only going to be able to store right? Because the number I've defined can only take 2 decimal places. But if it's a large number like 1, 2, 3, 4, 5, 6, 7, 8.12, everything so are people okay with why we would pick decimal for certain uses? Right. So for decimal, if you are very sure of the boundaries of your data, right, and for banks and even accounting, usually you know some range that, okay, I want to keep 3 decimal places of maybe cents or pesos. And that was the largest amount of money you could ever have. Someone could say, okay, maybe if it's just a school, maybe 1 billion. So someone could say, well, how many numbers do we have in a billion? Hey, is everyone asleep? Oh, pop quiz fast. How many zeros for a billion? All right. So, so if someone said, okay, let's do this. So question, I want to record 1 billion CDs with option of pesos, right? And one person says, let's write it this way, and another person says, let's write it. Who is correct and who is wrong? Okay, so vote. First one. How many people say first one? Hey, I feel like I must have pop quiz like every. I say a pop quiz. What's going on? Or are people thinking? Okay, so it has to be the B one, right? So that you can account for both the numbers that are leading the 0 and the numbers that come after the 0. So that means I can have a number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 positions, but up to here. So it means I can have something like, sorry. Is this a billion though? Let me check. Comma. Are you sure? I think I'm missing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry. 10, 11. I think I'm missing. To record 1 billion, I would need. Sorry. Isn't this 1 billion? The one here. This is not 1 billion. This is 1 billion, right? And so that means if I wanted my database to keep this, if I count the number of places 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, before 11, 12. I hope people are seeing how I came up with the number. Count how many numbers are what? Leading the decimal. Right. And add it to the numbers that follow the decimal. So that's the whole range. So in this case, 12. Right. And 2 are going to be used for decimal. So if I wanted to capture 1 billion in my database, I would have to specify decimal 12, 2. So that I can actually capture these digits. That means the largest number I can store in my database, in this case, is if I wanted to store a larger number, I'd have to just make sure that I extend this one. Similarly, if I want to store more fractions, I'll have to what? Extend this so that I can give this also a larger number. So for example, if someone said, oh, let's go up to 3 decimal places, I wouldn't just go and say, okay, it used to be this, and the person says 3 decimal places, I'll just go and do this. If I do that, I've shortened the other side, the whole number part. So I'll have to make sure I do, when I increase this side, I increase the precision part to make sure that it captures the decimal. So are people cool? I'm moving on with my design. Please, we'll have a pop quiz on Wednesday. It's not even pop anymore. So on Wednesday, I'll ask you about how do you create table, write a query for that. Insertion, primary key, foreign key. You should be able to do that, right? And yeah, you should be able to do that. You have already done some by yourself, and you're also doing some with your group. So if I say, well, I have a table, these are the columns. How would you create it? You should be able to write for me. All right. So this is data format for decimal. Right. So anytime you're doing a design, don't just be picking. For the few that have come in, I'm not penalizing this time, but just be careful what you are picking for these. Don't just pick. Some people just left everything varchar. Well, so since you are resubmitting, you can make changes to it. Not everything has to be varchar. If it's money or something, think something good for it. Or if it's height or length or number of items. Number of items, varchar is not very good. Right? Think of other things. Right? Or date. Some people are still leaving date as varchar. I know in some designs, people tend to use varchar so that they themselves can format the date. But if date is there, I would use it.
So for example, like a passport number, which has letters and numbers?
I would use them varchar. Use a varchar. Or even, there was another one, car license numbers. That's another one, where there's a mixture of numbers and characters. You can use a varchar. All right, so this is our restaurant. So currently we have student, meal, and a cashier. Now, if you are going to go and buy something, now some people are struggling a little bit because whenever they connect these, it makes extra tables for them. This thing is like a nice user interface, and it can create some things automatically for you. But if it creates something and you realize you don't need it, take your time and check each table to see what is happening. Right? I know some people just connected for me and are planning to send. But before you send, you go and click table by table. Just make sure, okay, what did it do? Okay, it says it's my primary key. Sometimes when you connect, it may add on, okay, let me just do one where I'm sure it will add on an extra. Like this. If I connect this, it immediately starts copying columns over, trying to replicate this idea that there is a many to one. In this case, one student belongs to a cashier. And it's trying to copy the primary key here so that you are forced to have an entry where you can enter that row's information in that table. In order to do a one-to-many, that's usually what happens. So if I want to record the fact that, so in this case, I have, okay, so this one even called student has cashier. This is like a purchase, someone purchasing food. So, student receipt. Right. On the receipt, I think in your canteen receipt, you have your ID on there. You may also have the person who sold you the items' IDs on there. Right. And the meal is also on there. Okay. But in our design now, I think on campus currently, you can buy more than one item. Right, on your receipt. When you're buying food, you don't just buy one thing. Right. If you were buying just one thing, it would be something like, so let me do the one thing and do the multiple, so people can see the difference. So, sorry. Sometimes I have to remember which one you click first before. All right. So now I'm having this design where I'm seeing it has added what? The meal's ID to what? The student receipt. What people are also observing is some things are double line and some things are broken line. Right? So in this case, what you are seeing with the student receipt is the student ID, cashier number, you went to buy food, meal ID, they are all together, the three things forming your what? Your primary key. And now that also means that a receipt cannot exist without what? A student, a sales, and a meal. Is everyone okay? The moment something is defined as primary key, you can't exist without it. Right. Now, the reason why these broken lines come in, so some of you are seeing broken lines, it is going to occur if, so for example, I've made one where the cashier, I've said, is no more part of the primary key. And what you are seeing is the line that connects to cashier has now become dotted. It means that the cashier is no more defining this receipt. The receipt can exist without a cashier. And so this can be a null. So if not null, it's there. But there's really, anytime dotted is there. So please note that primary key is what makes it thick. It's not the not now that makes it thick. Right. So it just means that if it is dotted, this value may not be required to make a receipt for you. Right. But the moment it is added as part of the primary key, that's why some of the lines are thick. So anytime I see a diagram, if I see a thick line, it tells me that, okay, the primary key is going to be sent to the other place to help define what the item is. Right. So a receipt cannot exist without a student, a cashier, or a meal. You can't just print a receipt. Hopefully, I hope that's how it works. You can't just go and print a receipt and charge money. They have to identify who the cashier is, who the student is, who the meal is, before what? They can issue a receipt.
For this case, can the same student buy the same meal and the same cashier serving?
Yes, you can buy as many. Okay, but there's a problem with this one, right? It means that the moment you buy food, one. So can I, in this case, buy the same plantain twice in a row? Yes or no? Why no?
The same student, same cashier, the same meal.
Yeah, that is my primary key. So the moment I have a second one, it will not allow me to buy another. I won't be allowed to buy the same food again. And so that means that this may not be a very good design for this table. At least for what we have here. If you send this to them, that means the moment you bought wache and beans, that's it. Forever and ever, you can never buy wache and beans again in the system. So as defined now, student ID, cashier, meal, if the three things form the primary key, then I'm not going to be allowed to have that same combination. So, okay, so if I make something weak, so let's play 3 games, right? So this is the first one. In this one, my restriction is... Sorry, there are 3 variations. I just want to make sure that I have a document capturing all 3. So the first one is can only buy food once. That's this one. So for example, student ID 1 can buy meal ID 1 from cashier ID 1. But I cannot buy the same thing again once I buy. You can buy the same thing from, so that's a good point, right? Because if you take SID, CID, and meal ID, I can do 1, 1, 1, that's fine. I can also do 1, 2, 1. So that means I can get what? The same food from another cashier. Are you sure it's not a problem? Think about it. Let's say right now, there's a woman there called Mercy whose ID is 1 and she's selling food. You buy, let's say, bread today. Can you buy bread tomorrow? Yeah, only if there's a different cashier. Right. But the problem is, if you don't get a new cashier, you are stuck. This design isn't going to work for you. Right. You thought it was? Okay, so let's implement this, right? Okay, so to implement, right now there is one primary key for student, one for meal, one for cashier. This is also one primary key, but three things form the primary key. So this doesn't mean that there are three different primary keys. This means that one key is composed of what? SID, cashier ID, meal ID. Yes, okay. So let's see the code for this. So please, once you finish the design, one of the reasons I wanted people to use this is, once you finish the design, you can export and get the SQL, the code that will help you what? Create your table. Right. So next. Okay, so this is the code. Copy to clipboard. I know people are saying, oh, and I was suffering. I was suffering. Okay, so it is good to learn both the code and how the tools work. Why do you need to learn? We will not divert too much, just so that we can. I'm just going to try and implement this quickly. Finish. Okay, this was student restaurant. Okay, so these are the tables that have been created. So first is, why does it want to be? Okay, so these are some of the reasons why you should learn the code itself. I have copied the code from what was generated for me. I would like to put this table into this database. The database is here called student restaurant. If I run this, will it put it in the student restaurant? It's going to put it where? Into something called my DB. More enlargement. This side hasn't enlarged, unfortunately. This is a student restaurant, right? And currently, if you look at the code that was given to me, it says mydb.student. So at the very least, even if you are using tools to help you, it's good if you can read the code and understand what it's doing, so that when it gives you code and it doesn't do what you expect it to do, you can fix it. Right. So I know that most of you, if that were the case, that we could just use automated tools. Then when you come to Ashesi, we'll tell you, what's that website called? We'll show you Microsoft App Store, Android App Store, and what other, let me see, SourceForge, they have code. So anytime we give you a work, we'll say you go online and download. But that will not be enough to sustain your bread and butter for the next 30 years. Because somewhere along the line, someone will ask you, oh, can you please provide us with this solution? Some people, when you graduate, I'm sure your job description will just be purchasing. Maybe you go, you purchase, you deploy. But some people, so now and then, you would have to either modify what you have or come up with a solution. And that's why in Ashesi, we take time to take you through all of this. Right? So I know that there are a lot of tools. There are tools that can do everything. Some of them, you can even just talk to it and it will start designing for you. But as much as possible, you must know some of the code in the back end. So in case it gets you something and it's not doing what you want, you can fix it. Right. So let's fix this. So one way to fix it is, I can remove this. So I know how to write a create statement. So I can remove the extra part. I've selected my database. So if I run this, it will work. Puts it in. Cashier, I don't need. Yeah, so this is how sometimes you can catch people who have just gone to draw from some system. Because there will be some things in there, like a thing like I know DB. People usually don't write that one. I know here it's written at the end. People are seeing this. I know DB, engine. Alright, so there are many engines. An engine is just a format along with different algorithms that are used to store the table. So InnoDB, for example, it uses some form of tree to store the information. But InnoDB is one class, someone's implementation. There's also my ISAM. That also uses a tree, but the tree is a little bit static. There are things like Falcon. They come and go. So over time, the data itself, this is the schema definition. But over time, different people have different engines, different ways to store the same information. Right? So InnoDB is one of them. Okay, so we have this big one, this student receipt. Who currently, and you see, is that all the foreign keys and everything? But in addition, it's now added this on delete, on update. There's on delete, no action. The options are no action and cascade. So if it says you delete something, that means on that foreign key, it will not go and touch the other table. InnoDB is static. What I meant by the class names may change is InnoDB currently has become very common, very standard. But it wasn't there maybe 10 or 20 years ago. It's something that over time, people would come up with an engine, develop it, and if more people use it and support it, it will be something that is in the default package. Right? It's almost like different types of fonts. If a font is designed and people use it, it becomes part. But I can't guarantee you that maybe in the next 5 years, it's likely to be there. But there could be another engine that becomes more popular.
So you use that InnoDB for database and it becomes inexistent in the next 5 years. How often do you use it?
So you'd have to migrate your table. Usually you can just, if you alter the table. So, just a second. Maybe I have to refresh this. My mouse is also misbehaving and playing with me. So, do this. Right click, alter table. One of the options here is, okay. Under options, you have InnoDB. So you can see there are many of them, many table schemas. So if you are finding out that, oh, this table will no more be implemented in the next version, you can export your data and then go and design, pick something that already exists in the upcoming version. So that when that time comes and you move over, you can still use your database table. Oh yeah, as long as you use the old version. So if you have currently this version you're using it and you're not changing over, that's fine. But what will happen is over time, and there are many of them here, they will come and go, right? But it's not something you have to worry about every single year. I think when the changes are happening, usually there's a lot of noise because, well, not noise, but developers would maybe make a lot of complaints, saying whether they want to move, they want to stay, and you will find out about it if you are a regular user of the system. So there's no need to fear InnoDB for now. Right. So this is my third table, student receipt, and I can implement this as well. Could not add. Okay, why couldn't it add foreign key constraint? Yes, I am. But why couldn't I add foreign key constraint? Why? I tried to add, it says cannot add foreign key constraint. But I've already created the tables. I created. No, I've not created this before. It's not in my student receipt. I don't have student receipt yet. This is a nice free question. So this is for those who are paying attention. So what am I doing that I'm not doing anymore? See, exam questions can be very nice. Eh? Scroll down. Actually, I'll let me give you a hint. It has nothing to do with the bottom part. It has something to do with the DB. My DB, I've not. Okay, so that's an error that some people are having as well. They create a database, and somewhere along the line, they switch to another one. And then their tables are no more working on if the foreign key is refusing. So in this case, what? If I'm using this and I want to create my DB, the other two tables are not there. So it's not going to work. So once I remove that and I run it, cannot. Oh, so what is now happening? Okay, let's see. I have created a mail. Okay, so there are three of them. Student is one. That's the primary key, SID. Cashier is one. But actually, this also tells you that you can't rely fully on the ID, right? Yes, because imagine if, let's say, you have relied on this. The thing is due tomorrow. You have done 100 tables in the system. You are happy. You are smiling. They are asking you, oh, don't worry, we'll be done. Done. And then 1 hour to time, you click. The thing is not working. You will have to come to the code and fix it. All right. So this is also created. I'm happy. I think I'm happy. It's already there. Already exists. Meal is also created. Already exists. Until I got to this one. And it's saying, okay. So I have to watch out for cannot add foreign key constraint. For me, what I tend to do is I will remove some of the extra things if I'm not sure what it's doing. Which reference?
Yeah, the foreign keys. The reference
Okay, so there are more references. That's a good one. They are very good. Okay, so I've removed those ones. Let me try again and see if it works. Now it's happening. Alright, so good job. Okay, so you realize that even if you are relying on IDEs, you must what? You must know some code. So that when the code is given to you and you are trying to implement, if there's an error, you can read. The worst case was for me, I would have just removed it and tried to see which line was giving me an error before I finished that. Okay, so now that I've made a student, a meal, and a cashier, right? I can do something like insert into student. Now I have SID, F name, and L name. 101 Kofi Mensa. That's one student. And also insert into cashier. And 201. Alright. So one student, one cashier. I also need a meal. Okay. The meal, I'm not going to put description in there, but at least a name and a description. Fufu and soup. Alright. So just that enters. Oh, there's no column CID. Okay, so here it is called ID, not CID. And finally, some meal. Now, if you are inserting, so what we were pointing out before was, if you are going to insert something into the receipt, just refresh. This thing is. Refresh this, refresh. Okay. The receipt is listing student ID, cashier's ID, and meal ID. So I can put in some meal, some cashier. Student ID. Okay, I said student SID. Alright, so the point was the student can't buy the same food twice. So if we click this, it gives an error. It's a duplicate. Right. So how are we going to fix this in our design? Sorry. This one. So how do we fix this issue? Some people have to make these changes to their thing before they submit. Right. When you finish making your database, you need to ask yourself what types of, that's why I said insert data into it. The purpose of asking you to insert is to test if your database can take the values that you plan to eventually put in. So if you are doing something like a canteen, when I say put in values, don't just put in, like, I know some people are just putting in values to make me happy. So you do insert into 111, just so that they can get some values in there. But please try to use it as an exercise to test if your database will work. So if this were a canteen, and we're planning to have 2 or 3 people purchasing food, when we are asked to insert, don't just say insert. Try and ask yourself, what data that if I insert can help convince me that this is a good database? Right? That means that, I can say, okay, someone bought this food, someone bought another food, he came the next day. So in my system now, I'm realizing that after this, I can't have the same student buy food every single day. After the first purchase from the first cashier, that's it. What can I do to modify and make sure that I can buy food every day? There are so many solutions. I can add. Okay, so I could add in a time and add that as part of my primary key. So that's one possible solution. Though there's a simpler one. Okay, so he's saying that you can add a date time, which can be a date. Add this as part of your primary key. So that anytime you buy something, if this is part of the primary key, then just for that time when you bought it, it's unique. And if it's one system, this is actually not my favorite, but add the date and time. Don't just do the date. If you do the date, but in some designs, the date will be fine. Because you realize that there are these telcos where they are running some promotions and maybe every day you can do it only once. Right? So in that case, if you added just date, that means that you are restricting the person to do every day you can do just one. Right? So you enter a date and not the time, just the date. Right? Or if you even do something that just happens once a year, you could add a year to it so that the moment you are inserted for the year, you can't re-register again. So another design. Okay, so we can also put in a transaction ID. So a lot of you are having sales systems. Okay, let me remove this. Right. So what some people do is they will add in just a separate ID and then not make these primary anymore. But what you are seeing is I am also having not now. Meaning that you can't insert something without having student ID, cashier ID, and meal ID. Right. So if I do this, then I should make sure that those columns that are required are not now. So you use not now when you want to ensure that the user provides some information. If not, insertion will fail. So I also tend to like this one. Now, auto increment here, it's not varchar, but as an integer. Right. Auto increment here works very nicely, especially for those things where you don't want to bother creating more and more IDs. So in that case, the system will just handle putting in numbers and numbering all the meal requests that are coming in. Alright, so is everyone cool? So the system that you currently have built, ask yourself those questions. So if you have a purchase, ask yourself, how many things? For the ER diagram, the one of the squares, diamonds, that one is usually okay. But when you are coming to this stage, ask yourself, what design I have, the information. So can put in some dumb information, put in 2, 3 purchases, 3, 4 customers. See if the things that you plan to do with your database will work. So if you want to have flights, ask yourself, can I put in a flight for a person going from one location to the other? Just dummy data. If meant someone wants to take a flight from here to here. Can you do it? So are people cool with this design? Okay. Now, when we talk about weak entities, so in the textbook, one of the things that's mentioned in chapter 2 is, weak entities. I'll just bring it up. Come on, move. Okay, enough people asked what the arrow was. I think now everyone knows what the arrow is, right? When you see the arrow on the... Or people didn't ask, just saw the arrow, you didn't read the text. Sometimes I leave something to see those who are curious. Those who ask me. Some people have not asked me yet, some people have not read the book. So you just saw the arrow and that was it. Okay, so what's the arrow? What does it say? Okay, so what's the arrow since you also read? Alright, so it means that you're enforcing that in this relationship, right? You can, so between stars and movies, there can only be a contract with a studio. So if I pick a star in a movie, so this, I like this thing very much because it actually is explaining something, right? So if, let me just pull this out and we'll do some sample data to see what violates this and what meets this criteria. All right, so if I have this, right? And in my database, I have a star contract table. Let's make sure everyone... I have the star name. I have the movie name. And I also have the studio name. So something like... movie, maybe Terminator, which I don't know the studio. Does anyone know the studio for Terminator? Universal. Okay. Okay, so hopefully we won't get sued by someone else if it's not the right thing. Okay, so what this is meaning is, as far as what this diagram means, if you see the arrow on one end, it means that if you pick a relationship, so contract, this is representing a contract. You have a name of something, the movie, and the studio. It means that if I pick these two, it should point to only one. I cannot have it anywhere that I should have another. Sorry. Let me. Move to the next. Okay. I cannot have also Arnold S. and maybe Sonny. So that is what really this means, that this is wrong. Let me just, where is strike through? Oh, I know I used to be able to do strike through. Okay, thanks. That's a good question. Yes, you can. So you can have Arnold. Oh, sorry, it's doing. Okay. So you can do this. So that's what the arrow really means. The arrow is with respect to that diamond. So anytime you see a diamond, what it actually should hint to you. So some of you will have to think about the diamonds in your tables. If you see a diamond, it means that it's now from what three things are coming together to form that relationship. And you should ask yourself, if you put the arrow, so if I put the arrow here, then that means that for any pair of things that I pick, it's to one studio. So what you would see in the diagram design you were doing was, I think a movie studio, all the movies belong to only one movie studio. Right. You could see it in the design because, sorry, see if I can, oh, this is not the text. Let me pull out the text. Sorry. 2015, dbms, have to remember which is which. Is it exercise 4 or was it the first exercise? I should group these into more folders, shouldn't I? Yeah. Oh, exams and all. Don't worry. I'll open the exam now. It's there though. Yeah, the exams are ready. I don't know why they want to do this. Come on. Okay, so what people should have, or some people noticed, some people did not, was that because they said movie was owned by one studio, right? If you look at the movie, they actually put the studio name into just a column, one field, into the movie table. And this means that you can't have a movie belonging to multiple studios. So this is in effect creating that one-to-many between movie and studio. So the studio didn't record any extra column. It is instead this movie table that had the studio name being recorded, and that made this one-to-many. Okay, so what the week would mean, right? So for those who are at least reading the text, going ahead. So today we are trying to capture the week, then we would end. Come on. No, that's not this one. Oh. Hey, where's my week? Oh, come on. No, that's not it. Okay, so this is an example of the weak entity. So when you say a weak entity, you mean some entity which cannot exist without being a participant of a relationship. Right? So this is what we mean by a weak entity. So in a database design, so that's why some of you, when you are doing it, I'll ask you, which relationship do you use? Which relationship do you use? You can have many relationships, but for example, you have studio and crews. So the crews are like those who are maybe doing lighting, doing all these people, right? So the design here is saying that if a crew is not within a unit that works in a studio, you can't be a crew member, right? I'm trying to find a good definition. It's like, let me see, saying that you are sick. Okay, that's not a very good one, because sometimes the disease is not yet identified. But for example, claiming you are a lecturer, but you don't have a university. It's a little bit strange. Or claiming that, let me see. Okay, yeah. So students now, there are some definition about student where they say, is that your profession? But if someone says you're a student, you would expect to know what university you are in. There's something like that. Or if you said you were a parent, they would ask you, where are your children? Or if you said, I am a husband, they will ask you, where's your wife? Or you come and say, I'm a wife, where's your husband? You won't just be, okay, I'm a wife. Okay, where's your husband? I don't have a husband, but I am a wife. But if you said you are a wife now, we would ask you, okay, who was your husband at that point? That would be. So I hope you understand the concept of weak entity. Right. So a weak entity cannot exist without participating in a relationship with something. So we call this the identifying relationship. Right. And you can see that when it actually does the double line in your workbench, it actually hints to the fact that somebody is weak with respect to some entity. Because if that double line is there, so those who are, let's just watch the details carefully. Okay, right now everything here has become a dashed line. But there was a time when some of this was solid. When it's solid, it actually is hinting to you that the item cannot exist without what? That other item. Because it's the primary key there is defining you here. You are more or less weak as far as that item is concerned.
But then making it a dashed line, you can do it because I think I tried
the table design.
The relationship.
Mm-hmm.
And they asked whether when you right click and they ask you to
like here.
The dashed line or
edit relationship.
I make it a dashed line. So does it mean that when you make it a dashed line, it makes it a weak entity?
So no. So the dash means that it is actually a stronger entity. So right now, as it exists, right, it's not requiring a primary key. Okay, because of the not null, it's kind of a little bit strange. Let me do it this way. So that means that I can have a row in the student receipt whereby I don't have a student ID, cashier or meal. So it means that the cashier, so in terms of fraud, so I mean that's why sometimes I talk about good designs. If you've done a very strong design, it's very hard, for example, let's say you've done payroll, and payroll is saying that you need to have an employee ID before what? You enter how much money you have to pay the person. Not just, okay, I make a row and I can add some amount of money. Right? If you do it that way, and the person can't even, and it's not required that the employee has to exist, that means that what? Someone can inflate it by just what? Adding, so for example, this one, if this were there, that means that it's possible that if you count the number of receipts, it won't match the number of purchases. Because some of them have empty student IDs, meal IDs. It's not going to tally. So what this is saying is this has, in a sense, it's now, without the primary key requirement, this is a strong entity. And you see, so she was saying that sometimes she could go in here and edit, so I'll do what she was saying. Edit the relationship. Right? And if you go, they'll ask you, is it identifying? You see, the moment I said identifying, it tried to what? Make one of the lines solid. Right? So it means that anytime you try and say something identifies something else, that means that he cannot, his identity is dependent on currently student. But you see the problem with this is he doesn't even know that I would have liked it to be three things. That's why it's good to know the design, to go through. Even though I've clicked identifying, it didn't pick all three. It just picked the first one that I saw. It made it thick. So it's always a good thing if you know how to modify these, go into the back end and check and make it represent what you intend, not what the diagram is doing by guessing.
And I also have a question. If you are creating the relationship, let's say you pick the one to many distance. Is it that the one you click on first, because the table is like you click on it and click on that and it creates a relationship? Is it that, let's say if you have one to many, if I click on student to cashier, it means that the student is the one and the cashier is the one?
Okay, so the only thing is, if you click on many to many, so for example, if I said meal and students, it will make a third table. That's what it always does for many to many. It always does a third table, because as far as many to many, it doesn't matter the direction. Right? But for the others, the direction and which one you clicked first, sorry, we do delete. Delete. Does matter. I've actually not memorized which one goes first, but somehow when I'm doing it, my muscle memory is able to do it. But if you do it and it's wrong, just flip it. Just go the other way. I've not memorized that it's the first you click, the second you click. But that shouldn't be like something that you are, what's the word? It's not something I'll quiz you on.
No, let's ask you. I just want to know, because the relationship I created is mine. I didn't really know.
Okay.
I didn't really.
So here's the thing. When you are creating these, you should always ask yourself, what is it doing, on your behalf? Right? Because this one here, this thing that is here, right? I could have done this by creating many to many. So I could have done this by saying, let me first create many to many between these two. And then, so it looks similar to it. And then I'm going to pick the one with the double line and do this. Isn't this the same design I started with? I started with student ID, cashier ID, meal ID, with thick lines connecting to everything. Right? So I've done it by clicking many to many first. I could also start with an empty table, and then I'm going to follow up and pick this to this. That's formed my first one. This to this. That's formed my second one. And this to cashier. See, I've done the same thing again, right? I have student ID. Well, the order is a little bit different, but I've captured the same thing. So what I'm trying to tell you is, don't rely too much on memorizing. Okay, if it's many to many, go and click here. I hope you understand my point.
Yeah.
That shouldn't be your focus. Your focus should be whatever the tool is. Yes, it's helping you many to many. It starts, but you should also ask yourself, it has started. What do I want it to be? I hope people are understanding. So if you do many to many, you realize, okay, it doesn't do what you want. or there's a change, it doesn't match your diagram that you want to have, double click it and edit it. I hope everyone is understanding. As for the tools, there are many. This is one of many. And all of them, if you go to, I think there's Microsoft Visio, there are many other tools that can do this. If you pick others, they will also join the lines in different ways. But what you have to do is, as a designer, when you start, you must what? Make some changes. And make sure that it matches what you want it to be in the end. Don't just rely on the tool to draw the lines for you. Question? Okay, so you and then... If it's many to one, I would not expect to see a linking table. Though you could, some people do the many to many and then they put a unique there to try and force that one of them will be occurring just once. The movie design. Okay, so is it this one? Okay. So between movies and studios, actually one too many, and it's hinted at that you don't need to have an own table. As I said, some people are making an own table and adding unique, which would end up doing the same thing. But that is overkill. You just need to have, since every movie, right, needs to know only the specific studio it belongs to, I just have to have a studio ID in the movie table to record or capture this information. Okay, so in this case, as I said, someone could make a different table for own, but I'm saying it's overkill. It's not necessary. Because you just need to identify that every movie belongs to one studio. So the simple solution for that, as you can see, was to simply have the studio name as part of the movie table. And that captures it. As opposed to go and make another table before you insert this movie ID, studio ID, and movie, you need to. That means you have something that looks like stars and like movie title, movie name, and studio, which is, as I said, it's a little bit overkill. There are ways to have a simpler design. Okay, so this question before I come to this side. Mm-hmm. Okay, so we looked at and said, for an identifying relationship, so that means that after today, when you do a design, and something is an identifying relationship, I'll expect that you make, this was supposed to be thick line. The reason why this is this way was, I think in the past they were using typewriters. So if you look at the very old articles, you'd see something like 2 lines, but that just meant they wanted to do a thick line. So for us, currently, if you are doing this, don't try and draw a diamond on top of a diamond. Just make the line thick. So this is a thick line, that's a thick line.
So let's see. So if we have a non-identified relationship, right, and it doesn't have, for the linking table, it doesn't have foreign keys in it.
Okay, so if you have a linking table, there will definitely be foreign keys. So, for example, I have stars to movies. This table, stars in, definitely has keys in there. Even non-identifying, it does.
But the foreign keys are supposed to ensure structural integrity. So if it's a non-identifying relationship, which means that it doesn't really depend on the other table.
Means it doesn't need it to exist. That is really the point of the non-identifying. Right. So, not needing it, so it's like, just, okay. So let's take, wow. This one, this design of mail. Sorry, let me move that other side so I can have fewer. Okay. See, okay, student receipts. There's someone else. Okay, the mail. Let me move the mail up. Right. So in this design currently, right, this receipt cannot exist unless a student's meal and cashier are defined, because it's part of its primary key. So when we say something is an identifying relationship, so someone can say, oh, this identifies it, this identifies it, and that also identifies. So 3 things are identifying that specific entity or that specific role. So that's what the identifying means, that without the definition in the other table. Meanwhile, there's another design I did here. This one, sorry, if I remove these, it's no more identifying. It doesn't need this table that I make. If I make my table this way, I don't need you to insert a student, a meal, and a cashier before I can put in data. I can just have one row where I just have a transaction ID and know what? No student, no meal, but I've recorded information. I hope you understand the identifying.
So, in a sense, it's like if you get the column and you say the column is not now, so you can never ever not have any information in it.
If it's not now, then it means that you need to provide something. That's why I unchecked it before. Not now means you have to provide something. So this one, even though it's not be recorded as identifying, because I put not now here, it means that I will have to go and get a student ID that exists. Because remember, I just can't put in a number there. I have to get a cashier, I also have to get a meal. So this is more or less an identifying relationship. With the way I've done it, it's a foreign key, and I say it's not now. So you have to what? Go and bring me something from the other end. So these diagrams are nice, but these diagrams are only half of the knowledge we have.
So they perform the same role, just different.
They perform the same role in different ways, right? But if I did this, that means that definitely now he's independent. He can stand on his own. Right, so there are questions, two from here. Mr. and, okay, so. Mm-hmm.
The phone has like problems in the studio's code.
Mm-hmm.
Instead of just the studio name, press C.
The producer number.
In the studio's column, there's press C.
Yes.
And then you move the producer C. And then I remember in the reading, it says something about there being a relationship between the two of them.
Between which one? Between the movie and the producer?
Yeah, the movie and the producer, and the same one in the studio. The studio name and
I don't think so. I think the producer C was an executive. So it means that a movie was produced by one of the executives.
so are we saying that the producer C comes from the movie executive?
It was coming from the movie executive.
What? It's coming from the movie executive. The two of them, like you have I mean, when I read the diagram, it might create an extra table and pull those factors out.
So for this one, all you need to do is maybe to add, you're supposed to add a movie exec. Remember that you can have, okay, let me pull that one up. Because I think that's also, throwing people off. Right. Just a sec, let me scroll up a bit. I was expecting more questions based on, I'm looking for the recursive relationship. So, from the questions that people are asking me, I've realized that the chapter is not being covered the way I would like. And after today, I don't want to come back to this chapter. Okay. So this is an example of, it's similar to the other one, where three things are being pulled in to define a contract. But here, so my point is, you don't always have to have just one relationship between two things. You can have the same entity participating in different relationships. Right? So don't be afraid. If you think of it and realize, oh, I might need another relationship. All a relationship means is it's a type of action that is happening. So in this case, a contract, a star is participating in a contract, right? And a movie is also being signed in the contract. And you are also having this contract, which is signed off by a studio. So this is capturing very similar to the previous one, but now it is using three different relationships to pull them together. So what is happening with that movie table? It actually has more relationships than just the one that was there. That's why I said, look at it carefully, read the text, and see what other relationships they participate in. Don't try and put, I know some people are just, they make one big diamond and everything goes in there. Right? But sometimes if you look at it, you can ask yourself, okay, this thing that I have here, what are the different actions that are happening? For example, lecturer teaches a course. Lecturer audits a course. Lecturer supervises a course. Lecturer invigilates. They are all what? Different types of things that are happening between lecturers and courses. And they are all things that the registrar records. So you might be sent to even go and supervise, sit in, review. But it doesn't mean that it's just lecturer teachers. There can be other diamonds that are being created, other relationships.
said we can use that with the more elegant way to show the relation between movies and studio.
Not weak entity. I just said having just one column. I think I've now missed. Okay, it's this one. I just said that having this one here, just recording these, because realize that all these are different relationships. The studio name, which is recording the fact that the movie belongs to a studio. But yes, you can make a different table to represent it, but it's much more quicker and cleaner to just what? Write the name of the studio in here. If you know that every movie will have just one movie studio.
So is that one that you're deducting marks from?
No, I'm not deducting marks from. I think we looked at yours and I said if you add a unique, then you can enforce it. But that's like 2 or 3 extra things to write. It would have been much quicker to just say movie studio, one more column, we are done. Right. But you can also, but the only thing is with that one, you have to write more code to accomplish the same thing. But this was much more straightforward. So for example, if I said a movie was to have, let's say sequel. If I was supposed to say one movie was to have a sequel, it would have been easy to just have movie specifying another title a year, specifying the sequel, as opposed to trying to make another table to make a sequel. So one movie can relate to another movie. I hope have people not thought of those things? Okay. That means that the text has not been read completely. Let me go and pull one. Just a sec. Let me do that type of relationship before I continue. Like this. Hey, does that mean that nobody... Okay. Alright. So this is an example of a movie where there is a relationship, but for one of them. So what it's saying is that a movie, right, is a sequel of a specific movie. Right. So if I go there and say, oh, I'm a sequel, so maybe Batman 2. I don't think it's possible that a sequel can be, it can be transitive, maybe Star Wars 1, 2, 3, 4, 5. But if you pick Star Wars 5, it is deriving from Star Wars 4 directly. Right now, I don't think they are doing sequels where it's like, okay, but I see the Avengers thing is becoming messy. They are breaking this model, where one movie points to 2 or 3 that they are pulling from. But I hope people are okay with this diagram. So just a sec, then we'll come to yours.
If you were to put this in table form, you have to.
You can actually just have one table, right? Because all it's saying is, because of the arrow, every movie can just point to its sequel. So Batman 2 points to Batman 1. But I don't need another table for that. All I need to do is, okay, so basically I'll just have to have create table. My table primary key was what? Title and year, right? Title, year. But if I want to have a sequel, the sequel will just be foreign key, so I'll have sequel title and sequel year. Title and year references. Hello. Oh, you are doing donors. Okay, all right. So that just means that I'm going to have the same table reference itself. Right. So I have sequel and title. That's my primary key. To capture this, I'm just going to do this. Just as a last modification. This would be, you can add not now. Oh, sorry. I don't need this not now. Okay. This not, if I said not now, then it means that everything has to be a sequel of something else. But not everything is a sequel of something else. So I won't add the not now. It means you can have a sequence, title, and a year. But this captures this design. I don't need another table to do this.
Sorry for hogging time.
No, it's...
So going back to the movie database, when you are setting up that attribute studio name under the table movies,
Okay.
would you make studio name foreign key?
So yes, here all of these Studio name, if it's pointing to another table, make sure it's a foreign key. If you don't make it a foreign key, then you are not using the dbms. Remember, the database management system has primary key. That will make sure things are unique. Foreign key will make sure that when someone is inserting data, the data is good. That means you can't insert things that don't exist. So if you have something like a cashier, that was the first example we started with. You cannot have a receipt without a student, without a meal, and without what? A cashier. You can't have those three things. So it means if you build something like that and someone came to you and said, oh, we printed out all the receipts and it doesn't add up, you tell the person it's impossible because your system was properly designed. So it means that every receipt that was printed, if you printed from my system and you tallied it up, it should add up to the number of receipts that were ordered. But if your database design was very lax, that is, students were not required, meal not required, of course someone can easily, even in the back, be entering some data that is not correct, and it's still what's being accepted. Right? And it's actually a very serious thing. I mean, this whole meal, it looks easy. You go and buy your food. But at the end of the day, your sponsors, the people who are sponsoring the students, or the people who are paying for the food, or they would like to see at the end of the day, okay, you said you sold to 100 students. Which are the students you sold to? What did they buy? It's a valid question. If someone is paying for it, even staff we are subsidized in some way. So they would also want to know, which staff members did you sell to today? Then you're coming to take this 1122 CD because they said every meal maybe they'll take off 1 CD off or 2 CD off. Or which students came to eat the foods that you so claimed was served. Right? So it sounds like we are playing, but it's serious business. This is very serious business. Okay, your question. The sequel, how would we implement it? Okay. So yes, it's one movie that follows another movie. Right. It can be anything. So for example, you can have maybe things that are like this. For example, maybe one student is mentoring another student. It's something like this. Yeah, so in this case, I just added sequel title, sequel year, and a foreign key to make sure that it points to the same table. In my... Oh yes, insert as usual. Just maybe the first movie, insert into movies. You have title and year. I don't know when the Omen came. Maybe 1984. But okay. Okay. I'm not very good with remembering when movies came out. And if the sequel comes out, you just say insert into movies, title and year, similar, but maybe the Omen 2, and maybe the next year, 1986. I'm not sure about when the Omen Part 1 and Part 2 came. Right. But if I want it to be a sequel, then I have to what? I have to add in the sequel title and the sequel year. Right. So that I can go and bring the previous guy. I think my naming of columns is not very good. The Omen 1980. So you have to have some way to reference your previous one. Yeah, then you just use the first one. You don't always have to put in a sequel. That's why I said this and this. If not now is specified, then everybody has to have a sequel. But I have not said not null or anything. Please, you need the data type as well.
Yeah, in creating when you're creating tables in certain this one, this is the length of
the data type. Okay, if you make any, so please for your design, watch. If you make any table like this one, it says name is 45 characters. If your name happens to be more than 45, it will refuse to enter. Right, so that's for cars. So please, when you are making it, you have to ask good questions. So if you go and design a database to someone, don't just randomly, just because you see I always do 200, you say, oh, Mr. Safman type 200, 200, 200. That may not work, because you could go to a place where you realize, oh, maybe people's names or the name of the item may be more than 200. So usually you have to ask questions such as, oh, how long could a name be? How long could a country's name be? Or even the decimal or description. Description, I said 45 characters. What if the description of, this is a project, it's another one that we are doing. What if the description of a project is more than 45 characters? So you have to make sure you allocate enough space. So ask questions and allocate enough space. Or it's, it depends on if it's not null or not. Right. So there are two things that, okay, here question, okay, trying to find, sorry. Oh, where did my table go? Sorry, have to find. I think I am lost. Hey, where did my queries go? Oh, I have two different workbenches open. That explains a lot. Okay, so if you are inserting data into a database, so please, those doing insertions, if you are inserting, make sure that the number of columns that you specify here should match the number of things that you are providing. If it does not match, you will get an error about the number of things doesn't match. So column count doesn't match. That's one possibility. Even if you are inserting it this way, this will be allowed if the ID field is auto increment or what is not required. I hope you are understanding. Just because you have a table that has 60 columns, it doesn't mean that when you are inserting, you have to put in all 60 columns at once. You have to ask yourself which of the columns are required. If it's primary key and it's not auto increment, it will be required. And if it says not now, it will also be what? It will be required. So if the movie does not say that everybody has to have a sequel, you can insert. Right. Unless you say not now, then it won't be what? It won't ask you to put it in. Okay, so last question before we go.
So I realized that when I was doing the assignment, I visited 3 movies, and the stars in. When I was presenting the stars in, I got an error because the order in which I arranged the movies is not the same order in which I arranged the stars in. And I don't know why I
Okay, so please, final one. This is a very good one. It's something people have become to officers to ask. So if you make a table like meals, and you have people who insert this way, I know some people insert this way. They don't specify the columns. They just say, because they are in a hurry, insert into meals, and they specify the values. If when you created your database, the order is not this, it will fail, or sometimes you go into the wrong position. So whenever you are inserting, I mean, it will work, the code will work. But my advice to you is, make sure that what you specify the name of the column and right along with the corresponding values. I know it is valid not to do so, but I'm saying for best practices, I would encourage you to what? To put that in. That way, even when the order changes, even when you're working on different projects, someone is inserting in a different order, first name, last name, someone last name, first name, it will all go to the right place. Else, one day you go and all your customers, their names will be swapped around. Right. So please try as much as possible to specify the columns when you are doing insertion. All right. So thank you very much for today. Please, there'll be a quiz on Wednesday. Hello. You are finished.